Hi, this is Subhashni again, and today I'm here to talk about understanding machine learning and its significance in different professions. I'm sure that you already have heard about machine learning. Machine learning or ML is a cutting edge technology that has revolutionized the way we process and analyze data, making it a crucial concept for individuals across various professions. Whether you are an IT professional, an MBA graduate, or someone in the field of analytics and data science, a fundamental understanding of machine learning can significantly enhance your skill set and decision making capabilities. We explored the essence of machine learning, its importance in today's world, and look in detail at unsupervised learning. So, then, what exactly is machine learning? It is a subset of artificial intelligence or AI that enables computer systems to learn from data and improve their performance on a specific task without being explicitly programmed. As you know already, in traditional programming, the rules and instructions are predefined, but not so in ML. The system learns and adapts based on patterns and experiences. Of course, for ML to happen, you need large volumes of data to extract meaningful information. ML encompasses a wide range of techniques, algorithms, and models, but they can be broadly categorized into two main types: supervised learning and unsupervised learning. So, let's briefly talk about supervised learning. Supervised learning is a type of ML where the algorithm is trained on a labeled data set. Yes, you have clear headers. Input data is paired with the correct output, allowing the algorithm to learn and generalize from these examples. The primary goal in supervised learning is to make predictions or classifications, and the common applications of supervised learning include image recognition, natural language processing, and predictive analytics. For example, a supervised learning algorithm can be trained to recognize spam emails based on labeled examples of spam and not spammed emails. Now let's understand what is unsupervised learning. Unsupervised learning, on the other hand, deals with unlabeled data. Yes, in this type of ML, the algorithm is tasked with finding the patterns or the structures in the data without any guidance about the right answers. Unsupervised learning is used for tasks like clustering and dimension reduction. Clustering involves grouping similar data points together, while dimensionality reduction simplifies the data by reducing its complexity. Unsupervised learning plays a critical role in uncovering hidden insights and anomalies in the data. Now, you may ask, what is the importance of machine learning for different professions? When you look at IT professionals, understanding machine learning is essential because ML techniques are used to enhance network security, automate routine tasks, and optimize system preferences. When you look at MBA graduates in the business world, ML is a game changer, and MBA graduates find themselves in roles which require data driven decision making. Here, ML can help in market analysis, customer segmentation, demand forecasting, and risk management. Of course, for analytics and data science professionals, ML is at the core of their work. ML algorithms enable data scientists to build predictive models, uncover patterns in data, and automate repetitive data tasks. When you look at the basics of unsupervised learning and real life applications of unsupervised learning, what do you find? You find that unsupervised learning is a fascinating branch of ML that doesn't require labeled data, and it excels at revealing hidden structures within the dataset. One common application of unsupervised learning is handwriting recognition, which we will see very in the next example. But here in front of you, you can see there's supervised learning where you get labeled training data. You train the model to correctly label data and use this trained model to label new data. Okay. But in the unsupervised learning, you get training data without labels. You try and group similar items together and then use the trained model to label new data. Now, here you may also look at the difference between classification versus clustering. So, classification you will find often comes under supervised learning, where you have clear labeling of the data into children and adults, and the model is able to differentiate between these by saying that the weight of children is in this range, while if the weight goes beyond that range, they become adults, and the height of children is in this range, and if it goes beyond, they become adults. However, in unsupervised learning, we only can do clustering, which looks and says that these are the similar values. Now, when you look at that particular cluster, you may label that cluster as a child cluster, saying that it has all the weight and height characteristics of children, while you may label cluster 2 as an adult cluster, saying that it has all the weight and height characteristics of adults. This, I think, should give you a very clear understanding about the difference between supervised and unsupervised learning. So, once again, let us look at the types of machine learning. You have supervised learning, where you get labeled data, direct feedback saying that they are children or adults, and therefore you can predict outcome of future. When somebody new comes, you can look at the values and say, are they a child or an adult? When you look at unsupervised learning, there are no labels. So you don't know who is a child or an adult. You first do the clustering and then find the structure in the data saying that if they meet certain values, they should be labeled as children. And if they meet certain values and fall into cluster 2, they should be labeled as adults. There is a third part called reinforcement learning. Here, there is a decision process, a reward system, and here we learn through a series of actions. Reinforcement learning is a machine learning training method which is based on rewarding desired behavior and punishing undesired behavior. In general, a reinforcement learning agent, that is the entity which is being trained, is able to perceive and interpret its environment, take actions, and learn through trial and error. Today, we are here to talk about unsupervised learning. And let's see how we can use unsupervised learning in the real life. Now, when we look at unsupervised learning for something like handwritten numbers, there's a process to be followed. First, let us discuss this and we'll see then how it is used in real life. Here you can see a set of digits, and what we want to do is digits extraction. The first step is actually data collection. So you collect a data set of handwritten phone numbers, and this data set consists of various handwritten digits and is usually unlabeled. Data pre-processing, where the handwritten data is unstructured, and techniques like image scaling, noise reduction, and image binary creation are applied to clean and standardize this data. Then you do what is called feature extraction. Unsupervised learning algorithms work with features from this data. Features may include pixel value, stroke direction, or curvature of lines. Then you do a clustering. The core of unsupervised learning involves grouping similar data points together. In the context of handwritten digits, a clustering algorithm can be used to cluster similar digits like k-means. For instance, all the digits 1 will form one cluster, 2 will form another, and so on. Finally, and the fifth step is digit recognition. Once the clusters are formed, the algorithm can be fine tuned to recognize digits based on the clustering results. If a new handwritten digit is then presented, the system should be able to align it and assign it to the appropriate cluster, identifying the digit. So, where is the real life application? You know that in many industries, banks, post office, educational institutions, and jobs, when you're applying for one, you have to fill up multiple application forms, right? Now, this is one of the place where unsupervised machine learning can help convert handwritten numbers into structured data. In the next video, we will see how this can be practically done.